Hello and welcome to Ms. Ma's Advanced Functions class. This is a mini lesson on binomial theorem, which we're going to be using a lot when we are expanding polynomials in order to find the instantaneous rate of change, so the slope of the tangent that's coming up. So I just wanted to make sure you guys remember this stuff. The binomial theorem is basically a tool that we use in order to expand something that looks like this, x plus y to the n. And in our case, because we're going to be using the difference quotient a lot, x plus h to the whatever it is. And in order to do that, we can use Pascal's triangle. So if I want to do x plus h to the 5, I'm going to have to create Pascal's triangle until the 5th row. It starts like this. We just have ones, and you just keep having ones on the outside. And on the inside, we're just adding up the numbers from the previous row. So 1 plus 1 is 2. Okay, then you have the ones on the outside again, and you add from the inside. So 1 plus 2, that's 3, and 2 plus 1, that's 3 as well. And we'll just keep going. I'm going to just keep going until I need to get to 5. So you can see that this is the second row because that's a 2. This is the third row, 3. The next one is going to end up being the 4th row. And we're just going to add these numbers together to get the inside of the row. 1 plus 3, 3 plus 3, 3 plus 1. And so that's for the expansion of to the 4. And then we're going to do one more because that's going to give us the 5th row. So 1 plus 4, it's 5, 4 plus 6, 10, 6 plus 4, 10, and 4 plus 1, 5. So that gives us the coefficients of the expanded polynomial. Okay, so in this case I'm going to have a 1, I'm going to have a 5, a 10, a 10, a 5, and a 1 as my coefficients, and then I'm going to use these to multiply by my variables. So basically the first variable is going to go in descending order. Oops, I can spell. Descending. And then the second variable is going to go in ascending order. So it starts with 0 and it's going to go to 5, or it starts with 5 and it goes down to 0. So in this case we're going to get x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, and then x to the 0. And then the h's are going to go the opposite way, so h to the 0, h to the 1, h to the 2, h to the 3, h to the 4, h to the 5. Okay? And if you have any coefficients that are 1s, you can just leave them out. They kind of disappear like ninjas into the night. So we write it out properly, and that's it. That's all you need to do to get it right. I'm just going to finish that off. Okay, so why don't you try x plus h to the 7 on your own, complete Pascal's triangle, and then come back to me. And bam, we have completed the expansion for this, the binomial expansion, and hopefully you got it right with this correct Pascal's triangle expansion. One more thing, if you would like and you have taken data, then you can actually use the combination to find each of the parts of the Pascal's triangle. So if you know your R and choose R and choose R on your calculator, then you can use it. This one would be, 7 choose 0. This one is 7 choose 1. This is 7 choose 2, and so forth. If you're not really sure what I'm talking about, that's okay. You can always create your own Pascal's triangle and just write it all out. And it doesn't take that much time, and it definitely is better than just expanding each one as we go and trying to multiply x plus h by itself 7 times. So hope that was helpful. Make sure that you know it, and I will see you in class.